Okay, you spent about 10 minutes making this chart. What are some things that you noticed after you made it?
Well,
or while you were making it even?
let's see. So, just all of this 11 row here, this is all zeros because 11 is 0, and anything multiplied by 0 is 0.
Okay.
Well, I also noticed some sort of like rings going around almost. So,
okay.
Start here. You have 1, 2, 3, 4, 5, 6, 7, 8, 9. And 10, and then 10, and then going down you have 9, 8, 7, 6, 5, 4, 3, 2, 1.
Oh, cool.
Then going back on this 10 row you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Uh-huh.
And then going up on the 1 row you have 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Okay, that's pretty cool.
This is probably because like 10 is negative 1.
Mm-hmm.
So if you start with 10 and then you just subtract 1 from it.
Okay, neat. Yeah, cool.
And then it's true for some of the other ones, so there's a lot of repetition.
Like, what do you mean?
2, 4, 6, 8, 10, 1, 3, 5, 7, 9.
Uh-huh.
Going here. 2, 4, 6, 8, 10, 1, 3, 5, 7, 9. And then down here 9, 7, 5, 3, 1. 10, 8, 6, 4, 2.
Okay,
and
cool.
Here, 2, 4, 6, 8, 10. And
Neat.
over here as well.
Alright. Anything else?
Oh, no, that's about it.
All right. Well, one thing that is interesting is when we talk about regular multiplication and regular real numbers.
Yep.
All the numbers except 0 have multiplicative inverses. So there's always some number that when you multiply that times that number you get 1. So like 3 times in a normal multiplication, 3 times what is equal to 1?
1/3.
All right. What about pi? Pi times what is equal to 1?
1/pi.
Okay. Do all the numbers here other than the zeros? So like 11 is equal to 0. So does 8 have a number that's its inverse, multiplicative inverse?
Well, let's see. 8, you'd have to, if you look down this chart here, you'd see the 1 here, and you would go across here to 7.
Okay.
So 7 would be 8's multiplicative inverse and vice versa.
So 7 is like 1/8.
Yeah, 7 is 1/8 too.
All right. And how about 5? What's the multiplicative inverse of 5?
So you start at 5 and you go down, and you see 9 here. So 9 would be the multiplicative inverse.
So 9 is 1/5.
Yeah.
That's pretty weird.
Yeah.
Do all the numbers have inverses other than 11?
Well, you can check and see. You can just for the 1, 1, 1, 1, 1, 1, 1, 1. So yes, they all do.
Neat. Do they all have something that when you multiply that number by something you get 2?
2, 2, 2, 2, 2, 2, 2, 2, 2, and 2. So yes.
All right. So what times 8 was equal to 1 again?
It was 7.
All right.
8 was 7. Yep.
Can you use the fact that 8 times 7 is equal to 1 to figure out what 8 times what is going to equal to?
8 times what?
Can you use the fact that you know that 8 times 7 equals 1
Yep.
to figure out what number 8 times what number equals 2?
So 8 times 7 is 1. So 8 times 14 would be 2, but 14 doesn't exist. So you have to 14 mod 11, that would be 3.
All right. Was that the right number? Was 8 times 3 equal to 2?
Yep.
All right. Let's try it for 6. 6 times what equals 1?
6 times 2 equals 1.
All right. So what should equal 6 times what should equal 2?
It should be 4.
All right.
And here it is.
Nice.
4. Yep.
Okay. Let's try it for a different one. 3 times what equals 1?
3 times 4 equals 1.
Okay. So then without looking at the chart, can you tell me 3 times what is going to equal 5. If 3 times 4 equals 1, what's the number that 3 times that number is going to equal 5?
Well, you have to do 4 times 5, so that would be 20. And 20 mod 3 is 2. So you should have 20 mod 3, 20 mod 11 should be 9. So it should be 9.
Alright, is 3 times 9 equal to 5?
Yeah.
That's pretty cool, huh? So actually, the interesting thing is that every number appears in every row,
Yep.
and every number appears in every column.
It's pretty neat.
Yeah, that's a special kind of multiplication table. That only happens for primes, but that's a really interesting fact in number theory.
Yeah.
So, like 9 is 1/5.
Yeah.
It's cool. Yeah, it's fun. Alright, hey, great work this morning.